What exists outside the observable universe's boundaries? Is it conceivable that there is a much greater multiverse and that our universe is but one among many? But before we begin, subscribe to our channel if you haven't. Let's continue. These issues are frequently explored in movies. Science fiction stories are rife with imaginative interactions between many worlds, from Oscar winners like Everything Everywhere All at Once to superhero blockbusters like Dr. Strange in the Multiverse of Madness. According to some cosmologists, the idea of a multiverse is more than just a convenient plot device. The concepts of parallel universes are not new to humanity. In fact, Edgar Allan Poe even imagined the presence of a boundless succession of universes in a prose poem he composed in 1848. Yet when contemporary scientific theories aiming to explain the characteristics of our universe predicted the presence of other universes where events take place outside of our reality, the multiverse idea truly gained fire. Our comprehension of reality is not comprehensive, by far, argues Stanford University physicist Andrei Linde. Reality exists apart from us. If such universes exist, they are remote from ours, inaccessible, and invisible to any kind of direct observation, at least so far. And because of that, some professionals wonder if the hunt for a multiverse would ever be truly scientific. If our universe is the only one, would scientists ever know? We dissect the various hypotheses on the existence of a potential multiverse, which might include multiple worlds with unique physical laws, and whether or not there might be several versions of you out there. Describe the multiverse. Scientists refer to the concept that many universes may exist in addition to the observable one as the multiverse. Some scientific theories that depict several conceivable scenarios, from regions of space in different planes than our world to independent bubble universes that are perpetually bursting into being, predict the possibility of multiple universes. All of these theories contend that there are other realities outside of the space and time we can see. This is the one thing they all have in common. Yeah, so why do scientists believe that there might be other universes? In his book, The Number of the Heavens, science journalist Tom Siegfried explores how ideas of the multiverse have changed over the course of millennia and argues that if there is only one of them, we cannot explain all the characteristics of our universe. Why do the basic constants of nature exist as they do? Siegfried is curious. Why did our universe have enough time to create stars and planets? Why do stars have the perfect amount of energy when they shine? We don't have answers for any of those issues in our physical theories. According to Siegfried, there are two plausible accounts. Initially, in order to explain the characteristics of our cosmos, we need fresh, better theories. Or, as he puts it, we're only one of many distinct universes, and we live in the one that's beautiful and comfy, he adds. Which of the more well-known multiverse theories do you know? The inflationary cosmology theory, which holds that the world grew exponentially and rapidly in the brief moments following the Big Bang, is perhaps the one that has received the greatest scientific support. Several observed aspects of the cosmos, including its structure and galaxy distribution, are explained by cosmic inflation. One of the creators of cosmic inflationary theory, Linde, claims that at first glance, the idea appeared to be science fiction, albeit extremely inventive science fiction. But because it provided explanations for so many intriguing aspects of our reality, people began to take it seriously. One of the predictions of the theory is that inflation might occur repeatedly, possibly endlessly, producing a cluster of bubble universes. Some of those bubbles might be places where physics acts differently from our own, so not all of them will have the same characteristics as our own. They all exist outside the scope of what we can directly witness, albeit some of them might resemble our own universe. What are some other concepts? The many worlds interpretation of quantum mechanics, the theory that mathematically explains how matter acts, is another intriguing sort of multiverse. The many worlds interpretation, put forth by physicist Hugh Everett in 1957, foresees the existence of branching timelines, or parallel realities, in which our choices have different consequences and occasionally have wildly different results. James Kakalios of the University of Minnesota is a physicist who has written about the physics, or not, of superheroes. Hugh Everett says, "Look, there's actually an infinite number of parallel Earths. And when you do an experiment and you get the probabilities, basically all that proves is that you live on the Earth where that was the outcome of that experiment, he says. Yet, the result is different on other Earths. This view states that if you had made different choices, several versions of you might be off enjoying numerous alternative lives. But, the reality you are experiencing is the only one you can perceive. Where then are all those other Earths? They all intersect in dimensions that we are unable to reach. This kind of multiverse, where multiple scenarios are taking place in branching realities, is known as a Level 3 multiverse according to MIT's Max Tegmark. You still have an atomic bomb in the many worlds interpretation, Linde explains. You just don't know when it will go off. And perhaps it won't in some of those scenarios. Tegmark refers to the several universes suggested by some theories of cosmic inflation as a Level 2 multiverse, where the underlying physics may vary between the various universes. You don't even know if, in some portions of the universe, atomic bombs are even viable in principle, argues Linde of an inflationary multiverse. So how can I get to myself if I wish to meet with myself? Can we move around multiple multiverses? Regrettably, no. At least not yet. According to scientists, traveling between universes is not yet possible. You cannot travel to these multiverses, claims Siegfried, unless a great deal of known and quite well established physics is incorrect. Who knows, though? I'm not saying that something won't be figured out in 1,000 years that you would have never thought of. Exists any concrete evidence that multiverses exist? There hasn't been any clear evidence to support the existence of a multiverse, despite the fact that some aspects of the universe seem to demand it. Thus far, there is only theoretical and, in certain cases, philosophical backing for the multiverse theory. Some scholars contend that the fact that the Big Bang created a cosmos that is just appropriate for human existence may be a grand cosmic coincidence. Others believe it is more plausible that there are several physical worlds and that we only live in the one that has the conditions necessary for our survival. According to Kakalios, the concept of an unlimited number of separate small pocket worlds or bubble universes, some of which have different physics or different fundamental constants, is appealing. That is why some individuals take these concepts seriously, he claims, as it aids in resolving particular philosophical problems. Scientists disagree about whether the multiverse idea can even be scientifically tested because it is, by definition, separate from our reality and unable to access. Yet it's possible that we're just lacking in the proper test. If our universe is simply one among many, will we ever know? Perhaps not. Multiverses, however, are among the hypotheses that may be tested in other ways, and if they pass all of their tests, then perhaps the multiverse also holds up. Or perhaps a brand new finding will aid researchers in their quest to determine whether the cosmos is truly all there is. Siegfried asserts, the universe is not limited by what little blobs of protoplasm on a tiny little planet can discover or test. We can claim that since it cannot be tested, it cannot be genuine, but that just implies we are unable to test it. And perhaps one day we'll discover a way to test it, or perhaps we won't. Yet, the universe is completely independent. Share your feedback with us in the comments section below. If you enjoyed watching our video, subscribe to our channel for more. Thanks for watching.